Hello there folks, once again it's Sunday, it's 8:22 in the morning and lockdown has ended, so I've got 2 church services to do, bearing in mind I work as a church organist, and I am looking at the time. My first service is 10 o'clock, it's only 4 miles away and I need to be there half an hour before, so I need to be kind of thinking about things at 9 o'clock and be away from here at 25 past. So, I've got 33 minutes to do a not so Sierra Hotel 1 Tango Sunday radio. Last week we'd run out of GT868s, which we hadn't already done. We've got some GT868s, but we've already covered them on Sierra Hotel 1 Tango Sunday. So we will do another PT40. I was hoping to find one with the PA, but I can't find one except a low TX40, which, as I've said before, is the better of the bunch, and we've already covered that. So this is a Eurosonic. Normally the Eurosonics are the GT868, GT858, but this was before those came out, and this, we hope, is not a Eurochronic. So I've just put a splice in the power lead in the negative there, because it was a bit too short. It's probably still a bit too short, but there we go. We'll put that into the power supply. This radio has actually come with a microphone. It's a standard generic Altai microphone, and that's absolutely fine. That can stay. A lot of the time when we buy batches of radios, if they've got a mic at all, it's one of those dreadful power mics that are so awful. I don't get the point anyway, because I mean, this is a throwback to American AM, isn't it? It's not. All the radios have some type of speech processing when they're FM, and when they're properly set up, that all that does is add distortion. So we've got a standard Altai mic, and what we will do is to remove the radio's bracket. I don't think I've ever seen a radio's bracket. So we'll just pop that off. Oh, it's got 2 screws this side. We are spoiled, and somebody's put a blooming mic clip on there. We'll get rid of that. Nothing better than drilling the dashboard of your car for the mic clip, not the radio. Best thing you can do when you get a new car is to start drilling the roof and all that. I don't get it. Do people buy cars for the next person or for themselves? I've known people keep the plastic on the seats of a new car so they get more money when they part chop it, and they've never enjoyed the wonderful upholstery, have they? The next person enjoys it. Right, so I'll get this unscrewed. It's got star washers, so I'll bear that in mind when I put it back together. So as I said last Sunday, you tend to find a version of the PT40 which doesn't have PA inferior in build quality to the one that does have PA, like it was on a different production line. And then the low TX40 is much better. So we'll just unsolder the speaker. We've got black to the left, which is negative, and I can't remember what we determined last week, whether that really was the negative end or not. So this looks immaculate. It doesn't look like anybody's ever been in it. And the biggest problem we had with these at the time, back in 1981, is that we had to turn the power down on quite a lot of them. So they were doing 5 watts out of the box. And the PT40s in general, one of the few radios that actually worked acceptably out of the box, apart from the fact we had to turn them down. Just like today, they did need to be optimised, and it was last used on channel 19, which there you go. So we'll make that sure that's in the off position. We'll connect it up to the test set. There we go. Right. So I'll switch picture in picture on, so hopefully we can see the meter on the test set. And I'm switching to the 3 watt range. We're on channel 20. We will be in a moment. There we go. does it transmit? And the answer is yes. And it's just gone to full scale deflection, so it's doing 3 watts. I'll switch it to the 30 watt range on the test set, and it's just a bit under on that range. So we'll start with the transmitter tune-up, and if I can find my notes from last week, which hopefully is still on the clipboard, here we are, PT40. I said the difficulty with these is coping with the delta tune, because if you set the frequency on transmit, the radio will be off on receive. Because normally you'd set the trimmer by the reference oscillator for the phase lock loop, you'd set it to your transmit frequency, which in this case would be 27.79.125, but you don't. You have to set it separately. So, just for the record, what is the frequency we're doing? So, oops, wrong camera. I'm always doing that. There we go, and let's see. So, 27. What? What's happened here? That's on European frequencies. Don't tell me somebody's gone and turned this into a Euro set. Oh, that's a disaster. $27,205. And the synthesizer chip, let's just zoom in. Oh, we've done it again, wrong camera. It's an LC7137, so that is UK. So I've gone and turned a pretty worthless set into a more worthless set. No wonder it's not doing the power these normally do. So it clearly says it's 2781 on the front. So something's happened to this. So I'm going to have to take the bottom off and see what has to be removed. This is going to be a really pointless exercise. That it isn't legal to put European channels on a 2781 set. Never has been. And our experience is that they never work properly either. I mean, that's off frequency, isn't it? It might not be trimmable. Right, see what they've done at the bottom. Oh, here we go. It's got some stupid piggyback board. Ah, dear, oh dear, oh dear. So, I wonder if the low power switch has suddenly become something else. So let's widen it. I've done it again, wrong camera. Now I've got the test set making a noise. There you are. So, a mile off frequency on UK channels. That should be 27.79.125. So you've got it, what, too high on CEPT. No, it's still low on CEPT. And, yeah, right. What were they thinking of? Okay, well, we'll get the soldering iron out and get rid of this illegal modification. Okay, we managed to get it back to some kind of working order. I've just been watching Radio Cruncher for 5 minutes while I was having my tea. I've done my 2 church services, and as ever I'm pressing the wrong button on here. So, we've actually got it back transmitting. You can hear it receiving, got it back transmitting. It's always a swine to try and find what they've done, and they cut a track just there, which I've just put a just soldered it across one to the other. But I couldn't see that. I couldn't see it with magnifying glass or anything, but I metered it and it was missing, so that's brought back transmit. So have we still got picture in picture? I think we have, but we're in the wrong. You want the meter. Okay, so where we left it, it was doing about 3 watts, and these sets are always a set I've had to turn down in the past. So I've done the first 3 transmit ones behind the scenes to get it to actually transmit, and then we'll move on from there with the other 2. I might have to put that on the spectrum analyzer and make sure they've not fiddled with it. That's the 54 meg trap, second harmonic. The other thing I will have to do behind the scenes is reconnect the high-low power switch. I can see they put a wire link in there to overcome the fact they'd pinched the switch for their illegal naughtiness. Right, so we'll just see if we can melt that. We need a bit more warming up today. It's 1 degree out, and it was about the same in church, as you can well imagine. For those of you not in the UK, the churches I work at, the 6 different ones, all Church of England, which is Anglican, and they're all 1,000-year-old stone buildings. So even if you have a few electric heaters kicking around, it's not going to do much. So don't need to imagine, you know, these are recent buildings. These are 1,000-year-old buildings, and of course that's absolutely wonderful. Well, we're over the 4 watts. Is this a hexagonal one at the back? Can't see. See if I can feel it. It doesn't want to move, whatever it is. We're doing 4 watts, but I'm just curious as to get this right, you know. No, it's not hexagonal. So it must be that one. Yeah, well, it's moving. I think the previous person's broken it, to be honest. Well, that looks to be peak, and that's 4.5 watts. So now we reduce it with the coil before. So we'll turn that down to 4, and there we have it. Now I have to go back on my notes, because the next bit we have to do with a frequency counter. So we need to set 10.24046 on capacitor 64's right hand lead. So there's capacitor 64. I'll just come in a bit. I've done it again. Okay, and I have to move the radio across a bit because the lead for the signal generator is a bit too short. Signal generator, what I'm talking about, frequency counter. 10.29, let's put that on for you to see. Oh dear, what are we going to get this right? Let's try the other input. 249. Well, that seems a long way to go. So we want 24. 24046. Well, that is pretty off frequency to me, so I don't know how we're going to compensate. So we'll see what we can do. What worries me is the receiver will be out. I think we're just going to have to do a bit of a compromise here. So that's now slightly high, so we'll pull it down with the frequency trim. Well, it's on frequency for transmit that way, but we'll have to check that it's on frequency for receive. That's not the way it should be done. Okay, so we're still doing 4 watts. Let's look at deviation. Now, yesterday we were doing those disappointing PMR 446 sets, so I just need to check the meters back to 27 megs. There we go. I think we're there. Wallow. Testing 1 2 1 2 1 2. We've got no audio. Testing 1 2 1 2. It goes from bad to worse, this, doesn't it? So first of all, we'll just check it's not the deviation control that's at minimum, and the deviation control is the one down there. Wallow. 1 2 1 2. Testing. 1 2 1 2 1 2. Let's put the monitor receiver on. Testing 1 2. Testing 1 2. One two. Testing 1 2. Testing 1 2. It's not set with a mic gain. Could be something really stupid off, like the wiring off the back of the socket or something. It could even be a duff mic, couldn't it? think we'll look at the mic. The screws are hanging out of this, so I'm not. I wouldn't be surprised if there isn't a wire dangling off, and that's why I've gone for the actual microphone plug first. To be honest, it's quicker to put a new mic to things. I think it's the number 1 standard. Let's just check. Looks that way. So we should have audio, screen, receive, and PTT, but of course we don't know what colours at the other end, do we? Because I don't want to peel it all back to find which one screened one is. They may even have got it wrong. I bought a record turntable and the phono socket, which is going to be 4 millivolt output. The fools have got telephone cable on it. No wonder it hummed. So apart from the fact it's falling apart, so we've got the audio is red and PTT is white. So looking back at the mic, audio is red, PTT is white. Yep, well that seems to tally. So I'll put the plug back together. And again, you can't always tell when you buy these things second-hand whether this mic has just been bundled with it and doesn't actually fit this set. And you can't, you know, if it said the make on it, that would be a possibility that it was the right mic, but it doesn't say make on it because it's a generic standard replacement mic. I'll probably lose the screw in the set and short it all out. Oh, we're getting somewhere. It's transmitting and receiving now, isn't it? So where's our audio? I'll get the monitor receiver back up here. One, two, 1, 2. And the thing to do now is just to prod the audio. You know what? I think the mic insert's open circuit. You can hear that. 1, 2, 1, 2. Right, I'll switch the set off and put an impedance meter on the mic. No, that's working. Oh, how strange. I think the quickest thing to do is to just try another mic before we start blaming the radio or blaming a duff lead. One, two, 1, 2. Wallow, 1, 2. Well, whatever it is, I've fixed it. Oh, well, testing 1, 2. There we go. So we'll get some deviation on it now, hopefully. 1, 2, wallow. Wallow, 1, 2, 1, 2. Wallow, wallow. Of course, I've messed with it, so. Wallow. 1, 2, 1, 2, 1, 2. That's it. 2.2, maximum of 2.5. Testing 1, 2, testing 1, 2. 1, 2, 3, 4, 5, 5, 4, 3, 2, 1. So, no idea what there was. Perhaps there's a bit of a duff wire in there. Let's see what the meter reads. Well, it should be the centre of the red zone, and it's the end of the red zone. So, VR1 is the TX meter. Centre of the red zone. That's the clipboard on the floor. I don't know why things always manage to get on an angle, but they do. Well, the receive's absolutely fantastic, so but I've got to check it's on frequency because of that snag with not being able to set CT1 properly. Well, actually, it sounds it's right, because can you hear it heterodyning? So in the off position, it seems right. It seems normal. Then in minus position, that's spot on. Okay, so we'll start with, can't remember, yes, detector is that one there. So I'll move this camera over to the oscilloscope, and I'll put S9 on. Maximum recovered audio. Is there. So that's an improvement. Right, we'll switch the cyanide meter on. So as usual, we'll get that to about, well, we'll try and get it to 4. So we'll go through the front end. Let's transmit. And now we're going to do the IF, and I'm having to turn this up a bit because I need to look at the quality as well. Now I've had some questions about this, and I will be showing this in the future, but not today. So I'm looking at quality and Synad together. Just go through those once again. Okay. Well, I've seen better, but I can't remember whether I've seen better on one of these. You know what? The RF gain wasn't at full. So I'll just check that final one again. Yeah. Not that the position that it was at has made much difference, to be honest. Right, let's look at the S meters. I'll put it back to an S9 signal. So that's 100 microvolts for CB in the UK, and we're reading actually spot on S9. That is absolutely on the button. So I'm not going to adjust it, but just for the information, if you haven't followed these before, it is S meter is this preset here. So we're going to we'll need to do the squelch. So that's that. I think we'll do the before we do the squelch, I think we'll look at the sensitivity. So we'll get the notepad out. So this time it's the Eurosonic PT40. So for 20 dB Synad, subject to it being able to produce that, because not everything can subject to the kind of noisy transistors are fitted. I've told you about the Hitachi cassette player, which had with noisy transistors before now. So, let's see, 20 dB. Well, we have got 20 dB on the screen. There's 20. So we're looking, actually, it's 0.9 of a microvolt. Well, that's rather good. 12 dB. See if we can change scales. Yeah, it's just on the border of 0.3. So let's go that way round. Yeah, it's 0.31. And then for the 10 decibel, the cheaty reading, it's 0.29. So yeah, actually more sensitive than I thought. So let's look at Squelch now. Tell you what we'll do. I'll park the signal generator at 0.3 microvolts. We'll switch picture in picture off. And turn the Squelch to full and see when it comes in. So 1 microvolt, 3 microvolts, 10, 30, 100, 300, 1, it never ever comes in. So we need to back that down so that it comes in at 100 microvolts. Now the Squelch lets these down is what I've discovered on other ones. So let's see. Here we go. Yeah, it's no better than the last one. So I'm going to have it at maximum sensitivity, which still doesn't open at 100 microvolts, but opens up at 300 microvolts. So it's about plus 20 it's opening up at. So now we'll turn the signal generator off, park it at 0.3 of a microvolt, and turn the Squelch down and set it at threshold. Switch the signal generator back on, and let's see when it comes in. Yeah, it's as bad as the last. It's coming in at 6 microvolts and leaving us at 5, and that's threshold. But I've set it for optimum, you know, what can I do? So yeah, a bit too strong Squelch on the minimum, and a bit too strong Squelch on maximum as well. So it just means that I have got this to rewire for the low power. So I'll pause the video while I do that. Right, I'm back into record. So one of the wires has gone back in, and the other one I put a little join in, and it marries back up with where they'd cut it. So hopefully we're now on. I'll just put the camera back on so you can see with the power level. I haven't tried this yet, so we're both going to see it work or not work together. Switch that back. There we go. So high power, 4 watts. Low power. Wow, it's nearly spot on 0.4 watts. Now they're not adjustable, and that's the first time I've seen one as close as that. So jobs are good on this, they say. So what we'll now do is put the radio together. So finally we've now got it on an aerial, and we better flick round without the Squelch because the Squelch is rubbish. One 919, Roger. Anybody out there? Only about 35 miles away. Okay, so there we have it. We'll do an on-the-air test, and then we can all see how well it performs. But with that Squelch, that's going to be the killer on it. So thank you for watching the Eurosonic PT40, which actually lives to fight another day.